Welcome to solverfy.
So this question is all about empirical formulas and then calculating a molecular formula from them. In every single portion of this question, we're given percent composition values, which is great because it's just like being given masses. In the first compound, we are given carbon at 92.3%. So you can think of carbon, and I'm going to do it for this one alone, 92.3 grams of carbon in 100 grams of our compound. Okay, so really we can think of this as 0.923 grams of carbon, and that's how I'm going to look at them from now on. I'm going to divide every percentage by 100 and use that as my mass. So 1 mole of carbon over its molar mass of 12.01. This gives me 0.0768 moles. Now, every time we're doing an empirical formula problem, we have to convert each element into moles so that we can find a mole ratio. Once you have them all in moles, you find the smallest one and divide your number of moles by that smallest value to get the ratio. So that's carbon. The next one is hydrogen. So for hydrogen, I'm going to do 0.077 grams. I just took the 7.7% and divided it by 100. 1 mole of hydrogen is 1.01 grams. This gives me 0.0762 moles of hydrogen. They're both pretty close. So when we divide these, I'm going to divide by the smaller one, which is the hydrogen. This is going to give me 1. When I do this division, I'm really going to get a 1 here as well. That means that my empirical formula is going to be CH. To find the molecular formula, we're going to take the molar mass of the compound, which they told us was 104, and I'm going to divide that by the molar mass of the CH. This is 13.01. So I'm going to divide this here. Based on their rounding, you could probably just divide it by 13. This is going to give you 8, which means I have 8 empirical formulas in this molecular formula. So the molecular formula has to be C8H8. Okay, we're going to do the same thing for each of these. They'll get easier as we go. In B, we have 49.5% carbon, so I'm going to change that to 0.495 grams of carbon. We're going to divide that by the molar mass of carbon, which is 12.01 grams per mole. That gives me 0.0412 moles carbon. Next up is hydrogen, 0.0515 grams divided by molar mass of 1.01 gives me 0.0510 moles of hydrogen. 0.289 grams divided by 14.01 for the mass of nitrogen gives me 0.0206. And the last one, 0.165 grams of oxygen divided by 16 grams per mole gives me 0.0103. So we're going to look at these. The smallest value here is the oxygen. So I am going to divide each of these by 0.0103. And they come out pretty darn close to whole numbers. So I rounded them all to the whole number. This gives me an empirical formula of C4, H5, N2O, because all of these numbers become my subscripts. Okay. Now, it tells us that the molecular formula has a mass of 195. So I'm going to take that 195 and divide by the molar mass of this compound. So 12.01 times 4 plus 1.01 times 5 plus 14.01 times 2 plus the 16 from oxygen gives me 97.11. And this rounds to the whole number of 2, which means I have 2 empirical formulas in my molecular formula. So the molecular has to be times 2, C8, H10, N4, O2. All right, we have one more. It's a little longer just because it has more elements, but the concept is the same and it's no more difficult, just lengthy. So for carbon, we have 0.3551 grams. I'm going to divide that by our molar mass. Gives me 0.02956. Then we have hydrogen, 0.0477 divided by 1.01 gives me 0.0472 moles of hydrogen. Next up is oxygen, 0.3785 divided by 16 gives us 0.0366. Then we have nitrogen, 0.0829 divided by the mass of nitrogen of 14.01 gives me 0.00592. And then for the last one, we have 0.1360 divided by 22.99, the mass of sodium, which also gives me 0.00592. So we're going to divide all of these by 0.00592. For carbon, that gives me 5. For hydrogen, it gives me 4. Oops. For oxygen, this gives me, whoops, I miscopied. It was 5 for carbon. When we do the second set of math, that's 8. Then we get 4. It would help if I could copy. Divide this one by basically itself, we get 1. Divide the last one by itself, we get 1. Which means my empirical formula is C5, H8, O4, N, Na, just in the order that they gave us the elements. They give us a molecular formula mass of 169. The mass of this compound is 169.13 if you add them all up, which means this is 1-to-1. And so this formula is both empirical and molecular.